internal shared state. Now, internal shared state, you can think of this as a box where you can fill the data, you can put the data, you can forward it to the workflow so that you can pull the data or utilize the data from the shared state and then do processing on top of it. And if a particular node is producing any output, they can put that output in the shared state and then they can forward it to the another hub. So basically, if you want to communicate with your agentic workflow graph, you do that using the internal shared state. So any input you want to give at the time of the starting of your workflow, you give them using the internal shared state. If two nodes want to communicate with each other and share some information, they do that with the help of internal shared state. And at the end, when the workflow is done and it is returning the output back to you, that is also done in the form of internal shared state. So this internal shared state, you can think of this as a single copy works, and at the end, once the workflow has executed, it returns the final response of whatever it is there in the internal shared state back to the user. So this is the core concept of a land graph. And is there any doubt? If you have any doubt, feel free to ask this right now. Any questions? So I'm happy to take it up in the comments. Or if this is clear, you can just type yes so that I have an understanding that this is clear. Is there today any practical? We can say yes. Probably then we'll talk about what we are building. We'll do a practical code walkthrough of the agent which we are building. Okay. Okay. Now regarding explaining it briefly, let's move ahead and let's see if you're able to catch up. And if you're not able to catch up, just let me know at what point you are you're not able to understand, and I'll definitely explain the topic again. Okay. Cool. So let's talk about another very important concept, which is very extensively used in the GenAI world. That is tool calling. So how many of you have heard of tool calling already? If you have, you can just type yes, or if you have any idea, or if you have used it before, you can also type yes. Okay. Okay, I guess majority of people, or I guess a couple of people have heard of it. A lot of people have not. So let me explain it this way. Basically, the large language models, if you have read them thoroughly, they are basically deep neural networks. And yeah, so this is basically deep neural networks, and these are like an autocomplete engine, and it is not very good at performing certain things. So these large language models are very good at answering natural language tasks, right? Reading the natural language and all, but the things like performing mathematical calculation, doing some logical work, the large language models might struggle at these, and there are some things which you can achieve via tool calling. So tool calling can be used at those parts where you know that this particular step, you know how you want to execute a particular step or a particular series of steps, then you can encapsulate that in the form of tool calling, and you can provide that to the model. So the concept is you provide the model multiple tools, and the model understands that this is a tool which is provided to me by the user, and I can use it whenever I want and whenever I feel like, right? For example, suppose you have a large language model and I provide it two tools. First tool is a web searching capability, and the second tool is a calculator tool, right? Then if I provide these two tools to the large language model, then the large language model has this idea that, okay, I have two tools with me. One is for calculation, or one is a calculator tool which I can use to perform mathematical calculation. The second one is a web search tool which I can use to query or to look for something in the on the web, right? So if I go ahead and I ask a question to that particular model with the support of the tools, that hey, can you tell me what is 3 plus 5? Then the model can know that okay, this is a mathematical calculation. Maybe I can use the calculator tool to answer it, and then it can outsource that particular calculation work to the calculator tool and can get the response back. Similarly, if I ask my model that hey, can you tell me what is the latest news happening today or happened an hour before, then the large language model will know that okay, in order to get the news an hour before, I need to perform a web search, and it knows that it has been provided a tool for web searching, so it probably searches the web. So it can probably give the query to the tool, and the tool will perform web search, and it will give the response back to the model, and then the model can return it. So this is what actually tool calling. And recently, this concept of tool calling is also being used in the concept of MCP, that is Model Context Protocol. I hope you have heard of MCP. It's been in the news a lot, and it is basically inspired by tool calling, where instead of providing tools, we provide server endpoints to the model for them to hit it. So basically, if you think that a model, suppose there is a database server which you think the model can query in future, we can provide the MCP endpoint of your database server to the model. Then the model can hit that particular MCP endpoint to get the data from the database. Now this is again one advanced concept of tool calling in the form of MCP. Now, is the concept clear? And if it is not, feel free to put that in the comments. So, is the response put ourselves before or AI analyze itself and answer the user 3 plus 2 equal to 5 example? Can I use it to test it? Okay, Shubha, I am not able to understand the question. Shalja, can I use it to test APIs? Yes, you can use it to test APIs, but I don't think that would be a right use case of MCPs, because if you want to test your API, you can definitely use Postman for it. The major use of MCP is to make sure that whether your large language model is able to call your API when they actually need, or basically when they are provided with some user query that requires them to hit that MCP to get the response and then leverage that response to answer their query, then they should be able to call it, and that is the actual idea. Okay, and I hope this is clear. Any questions? I'm happy to take. Okay. Yeah, sure, Neeraj, you can put the question in the comments and I'll be happy to answer. Would it be useful to generate test queries for the API calling? I'm not sure. What do you mean by test queries for API calling? Can LangGraph be integrated with PyTest or other testing tools? Yes, you can integrate that, but again, I am not sure what is the use case you are targeting for, but yeah, definitely I think it should be able to integrate. And let's move forward and see what actually tool calling in action is. So basically what we want is that we want to see, we have gone through the theory of tool calling. Let's see how we can actually make tool calling, or how tool calling actually happens in the large language model. Okay, what language is better for GenAI, Node or Python? I will suggest to go for Python, not because Python is a better programming language or Node.js is not. It is because a lot of research and development for agentic, for GenAI and related frameworks is being heavily done in Python, right? And the community support is also really good in Python. These are the two major reason I recommend Python for doing GenAI, machine learning and stuff, because there's a lot of support of doing like GenAI things, machine learning things in Python, and they have a very good community support. When to use tool calling and MCP for an agent, it depends. If you have, if you know that whatever you want to achieve, you can write a logic on your own, then you can use a tool for it, or basically you can define that in a function and call it a tool and bind it with the model. But if there is something which you cannot write, or you don't have the capability to outsource, or basically you don't have the capability to implement yourself, and there is an external server for it to implement, then you can use MCP. Classic example, suppose you want to get, suppose I'll give you my user handle for LinkedIn, and we want to grab my profile information for LinkedIn, right? There is no way you can write a tool for it, because LinkedIn is an external organization. So we have to connect with their MCP, or basically you have to connect your AI agent with their MCP, so that whenever you give, or whenever you ask your agent to fetch your LinkedIn profile information, your agent can hit the MCP of LinkedIn which you have provided, and they can get the information from LinkedIn, right? Okay, like someone mentioned some time ago, can you explain if the model will provide the answer by itself instead of calling the API? Yes, the model can provide the answer itself, and if the model is able to provide the answer itself, then there is no need to perform tool calling. Basically, tool callings are done to outsource some things which models are not good at, or basically if there is something where you think that a model can hallucinate and you know exactly what you need to do, instead of outsourcing that to model, you can use a tool calling. You can let the model do the tool calling. It will also save you some cost as well, right? A classic example is, suppose there is an AI agent or a large language model. I am providing two tools to this agent. First is to add two numbers, and the second is to get the length of the string, right? When I give these two tools to the agent has this in mind that if there is a query which requires me to add two numbers, I don't have to do it myself. I can outsource that to the tool. And the fact that you have implemented that tool, if an agent is outsourcing this work to the tool, they are not doing it themselves. So you can save some money, and if there is a case of hallucination, if this work was used to be done by the AI, then you can also save that. So you are making a fault tolerant AI agent, right? Same for getting the length of the string. If you are providing a string and asking for the length, the agent will know that I don't have to do it by myself. There is a tool provided to me. I can simply use the tool and get the thing done, right? Now, this is how the tool looks like. Currently, this is implemented in TypeScript, but when I do the walkthrough, I'll show a walkthrough in Python. So you can think of this as a very simple addition function. The only thing is that I am adding some description to the function. So this is an add tool where the name is add, description is add to integers, and the schema is taking two numbers a and b, right? And the implementation of the function is very simple. It returns the sum of a plus b in the form of a string, right? On the right side, there is a length tool. What it does is that it finds the length of the string, and the schema is very simple. It takes only one string, or and the implementation of the function is also very simple. It directly returns the length of the string, right? Now, if I go ahead and I'll provide this tool to the model, and if I ask a question, say, on the left side, add number 5 and 4, and also find the length of the string crocodile. Now, in that case, the sum of 5 and 4 is 9, and the length of the string crocodile is also 9. Now, this is okay. But if you will see under the hood what the model has done, and if you will see the response returned by the model in detail, you will see there is an object which model returns whenever, suppose you are talking to the model in LangChain, or you're directly calling that model through the company's SDK. You'll see a tool calls object which is basically a list which mentions what are the tool which the model wants to call. So here in the tool calls, there are two tools which the model wants to call. The first one is the function name add, and the arguments are 5 and 4. And the second one is the function name find length, and the argument is string crocodile. Now the interesting thing to note here is that you have given the query to the model in a natural language, and the model is itself figuring out from the natural language what should be the input parameter for the tools or for the methods. And here, then you can execute that tools with the argument which is provided by the model, and then you can return the response. Or you can also let the model execute these tools on behalf of you and get the response, and with the help of the response get a summary output like this, which is returned by the model on the left, right? But in order to do that, it has performed these two tool callings, because like in the tool calls, these two calls are mentioned, and what was the method and what was the argument which this method was called, this is also mentioned, right? So this is how a tool calling in practical looks like. You can use it for a lot of different operations. Okay, and if this is clear, you can like just put yes in the chat, or otherwise if there is any queries, just let me know in the chat and I'll be happy to take that up. Shouldn't tool mean API, right? Now it depends. Tool also means functions, and when you're talking about API endpoint, then tool is nothing but it's an MCP. It's a standard model control protocol which lays out the standard protocol for a large language model to talk to a server endpoint. So we are passing the whole function to LM. Yes or no? Ideally, what happens is that you bind these functions to the model, and the model has the capability for us to bind functions to the model. When we bind the functions, basically the functions have descriptions, and the input parameter to the function also has the description that is provided to the model, saying that hey, this is the tool, this is what it does, this is the output it takes, and this is what the output is all about. So the model has an idea, okay, this is the particular function, this is what it does, it takes these outputs, and this is the context of these outputs. So when you're giving a query, they are able to understand that which function to call and what inputs to pass, right? So that is, so I guess we don't need to pass the entire, or internally the entire function is not passed, only the context of the function and their input arguments are passed, so that the model can easily or correctly identify which function or to call. Okay, I hope that answers the query. How can I rewatch the webinar as I missed major parts of the session due to the internet issue? This webinar is, I guess, recorded, and it should be live streamed on YouTube as well. So I think there should definitely be a way for you to rewatch. Okay, will tool call reduce the cost of the LLM call? It depends. Again, the question is, when you are performing a tool call, you are doing an LLM call, which now is not doing the actual job, but it is actually thinking that which tool to call. So you are doing an LLM call, but if you are doing a very heavy lifting, and if your tool is actually doing which was like earlier done by a large language model, then you can definitely save some cost, because now the large language model is not doing that entire work. It is just identifying which tool to call to get that work done, and the entire work is done by the tool, right? By the function call. So you can definitely save some calls, because there is less tokens given to the tool and less output tokens received from the tool. And most of these large language models like charge you on the basis of the tokens which you fed into the tool and get back from the tool. So I feel this you should save some cost, and you should also save some time, because in general the inference time of these models are larger, very much larger than doing that work programmatically, right? So you'll save some time, you'll save some cost. Can we consider cascade of models as a tool call? I'm not sure what do you mean by cascade. If you like, let me know if you can elaborate this. Mayur asked that the flow is like the instruction LM tool which will do the actual work. Yeah, something like that. It will be more clear when we talk about when we do something practical, right? Name some Python framework and tools used on daily basis for this, like for Flutter, VS Code, Dart, Postman. The Python framework, there is no Python framework as such. There is a framework which I talked about is LangChain and LangGraph. It is available on Python and TypeScript as well. It is highly available in Python because the development is actively going on in Python. Okay, a question by Irish. What role does tool calling play in automated systems? Again, if you think that you have a particular operations laid out and you know how to perform them, it's better to put that in the tool and let the large language model execute the tool on the behalf of yourself and not the large language model doing the actual work. That is, I think that should be the number one idea when you are actually building the system in production, because in productions things can fail, large language models can hallucinate and things might go wrong. So it is better if you think that this, you know how this particular thing needs to be done, put that in the tool and let the large language model execute on your behalf. That has a very, very less chance of failure, mostly 0% chance of failure. So that should be the goal, that should be the goal of an AI engineer. Whatever you can do programmatically, do that. If you think that something is fuzzy, it can't be automated, it's very general, you don't know what logic should be there, give that to the LM and let the LM do the work, right? We can say LM is a thinker. Yeah, LM is a thinker. LMs are very good at answering multiple choice questions, identifying which tool to call. So they are very good at doing these natural language processing work. Okay, cool. Lots and lots of questions, but we have to cover a lot of content as well. So let's talk about RAG. How many of you have heard of RAG before? If you have, just add yes in the comments. If someone has built it, just type yes, build it. I'd be very happy to see that okay, some people have actually built RAG. Yes, build it. Okay, Neeraj, awesome, great. I have heard Hugging Face, not RAG. Okay, Hugging Face is again a company which has written a lot of libraries like Transformer, not the Transformer, actual Transformer. They have a pretty famous Transformer library. They have like a lot of things which you need to do with the large language model, like fine tuning it, inferencing it. You can do that with Hugging Face. Hugging Face also is a standard platform for hosting open source model, hosting your open source machine learning work. A lot of these things are there for Hugging Face. Okay, I guess very small amount of people have built RAG. So here what we'll do is that we'll build a RAG, but along with RAG, we'll give it an interesting web search capability. So here, the RAG which we'll be building here in this session, this will be super smart, and I'll tell you how it will be super smart. So we'll be covering three things. First, we'll see RAG pipeline, how a standard retrieval augmented generation pipeline is built from scratch. Then we'll also understand what role does vector store plays in your RAG pipeline, and we'll also see how you can let your large language model perform web search through tool calling, right? These are the three things which we'll cover. We'll also implement these from scratch. So let's quickly see. Okay, let's quickly first talk about what is RAG. So, Retrieval Augmented Generation System, this exists because the large language models are trained on a huge amount of data. They have an understanding of the entire world data, and that is the whole reason that they can hallucinate on small specific things, right? So suppose there is an airline company which has FAQ documents, right? And those are very specific questions, and to which they have very specific answers. And if you probably ask these questions directly to a bigger model like GPT or Gemini, they will probably not be able to answer that well, right? Or suppose you have some internal documents which is not present on the internet, and that is why any large language model will have no idea about it. And if you ask a Gemini model or GPT model question on these documents, will not be able to answer it correctly. And the third thing is these language models or these large language models has a knowledge cutoff. The concept knowledge cutoff means when a particular large language model is trained, after that any information coming onto the web, coming onto the internet, that model might have no idea about it, right? And that is called the knowledge cutoff. And training these models, fine-tuning it is a very expensive process. So it is not feasible for the companies to do it on a daily basis. So that is why there is always some knowledge cutoff for the models, and that's why these frameworks like RAG can be very helpful. Okay, and now let's see what RAG does. So the first thing is, suppose you have some documents that can be an internal documents, that can be any document which you want your large language to be trained on. These are a chunk of documents, and these are also sometimes called knowledge base when we in the terms of AI engineering. So you can think of these as documents on a knowledge base. These documents are split into smaller chunks or smaller pieces, and then this is converted into vectors, right? And you can think of vectors as a numerical representation of the text document. And why we do that? Because the large language models are again deep neural networks, and these are not good with text or letters. These deep neural networks are good with numbers. That is why whatever data you take, you convert them into vectors, a series of numbers, and you store them in the vector database, because this is a particular database which the large language model understands. Okay. Now this RAG pipeline is divided into two steps. The first one is data indexing, where when you ask a question on the basis of these documents or knowledge base, then the first thing what happens is that we get the relevant document chunks from the vector database for that particular user query. Now when I say relevant chunk of documents or top K chunk of documents, I mean that those documents where the probability of answering the user query is very high, because this particular documents or knowledge base are very huge, and it is not feasible and not possible to fed the entire document, provide the entire document to the model with the user query, because two things can happen. First is that if there is a lot of details, the model can hallucinate, and the second thing, every large language model has a fixed context window, so you can pass a limited information to these models, right? So that is why we perform data indexing, and after that we perform data retrieval and generation, where from these top K document chunks, we feed these chunks to the large language model with the user query, and along with that, the model tries to answer the particular query from the top K chunks of the context provided to the model, and it gives you the response. Now this is what a retrieval augmented generation pipeline is. Okay. Now moving forward, I've already explained the problem of knowledge cutoff, so we're going to skip this. And this is we have split the two steps, data indexing and data retrieval and generation, separately. On top of data indexing, where we have knowledge base or a lot of documents, and we split these documents into text chunks or chunks of documents. We convert these documents into their corresponding vector embeddings, and then we feed these vector embeddings into the vector database, right? After that, once we have the vector database with us, whatever the user query is, we convert the user query into the vector embeddings, and then we look for the relevant documents for the particular user query vector embeddings, and we extract top K documents. Now the value of K can be anything. It can be 5, it can be 10, it can be anything. So suppose if I take the value of K to be 5, then I will pick top 5 document chunks on the basis of the user query. A top 5 document which it seems very relevant to the user query. And then we provide these top K documents along with the user query to the large language model, and we get the response, or we get the answer back, right? So the model tries to answer the user query on the basis of the top K documents which is provided to the model. So it uses these top K chunks of the top K documents as a context to answer. and then it returns the response. You know how the retrieval augmented generation system is built. Now these are some code snippets for getting the vector chunks, for getting the relevant documents, for answering the query, and this is what we are building here. I have already explained RAG, but there is an additional thing which I have added here. That is whether a RAG can answer a query or not. Because there is a lot of time what can happen is that a user can answer a query which is not relevant to the knowledge base, and in that case the model might not be able to answer that from the document which has been provided. So what it can do is that if a RAG workflow is not able to answer your query, it will do a web search. So it will search for this query on the web, on the internet, and it will try to fetch the answer from the web for that question, and it will give it to the user. If the RAG is able to answer, then it will directly give it to the user. So we are making this RAG workflow fault tolerant and less prone to failure. So even if you are asking some irrelevant or out of the box questions, it will do a web search for those questions and it will try to answer it. Now there is a very relevant project which you can build, because we are going one step ahead of a traditional RAG framework or workflow, and we are adding web search capability inside it, right? Okay, cool. So this is one of the code base, or one of the code snippets where we perform the web search, and this is how we decide whether to perform web search or whether to get the answer directly from the RAG. So when the workflow or when the RAG workflow gives me the documents, I see the score. So whenever you get the documents from the vector store also gives you the value where it says how relevant this particular document is to the user query. And if all the documents, the score threshold or the relevancy threshold for all the documents is greater than 30%, then we will see that, okay, the question which is asked is relevant to the documents, and I'll let the RAG workflow answer. If the score threshold is less than 30%, then I'll assume that the question which is asked is irrelevant to the documents, and I'll do a web search. And this is how it will be done. So, is this clear? Is what I have explained is clear? If yes, you can type yes, and then we'll move on to the code walkthrough. Okay, cool. Happy to see that things are a bit clear. It will become clearer when we'll actually do the code walkthrough. So let me quickly stop sharing and let me share again my IDE. Okay. Is the code visible to everyone, or do I need to zoom it a bit more? Yeah, this will be answered. How can we identify score threshold? This will be answered here itself. So, are you able to see the code? Give me a yes if you're able to see it. If you want me to zoom it in a bit more, okay. Okay. Yes, no. A bit more. Okay, good. I will do a bit more. Okay. I think they should be okay. So the first step is to import the libraries. All of these libraries are open source libraries, so you don't need to worry about. I'll also quickly load the knowledge variables. Now, the thing is, the knowledge base, I am using an FAQ document of an airline company. The airline is Swiss Airlines. I'm using their FAQ documents. Now, their FAQ documents are very huge, and we have a lot of queries answered of different users. So, what we'll do is that we'll build a chatbot which you can ask some questions related to the Swiss airline company. If you're facing any issues, the chatbot will be able to answer because it has the FAQ document as their knowledge base. If you will ask any question which is not related to the airline, then it will do a web search, right? So let's first pick the document. I have printed the first 500 characters of the document. It looks like this: invoice questions. Can I receive an invoice for my booked flight? Answer is yes. Like these, there are lots and lots of questions. I've just printed the first 500 characters. I can go ahead and can print a lot, but this will gonna clutter the notebook. So I hope you get the gist. After that, we're gonna create the model. So to get the OpenAI client, we'll use the OpenAI library is present in the LangChain. And this is interesting, how to get a vector chunk. So we get the document from the source FAQ. We convert this document into chunks and we store that in the document. After that, we convert this particular document into vector embedding. Now, this is a piece of code which does that for you. We select a model, basically the embedding model, through which we want to convert the text into the vector embedding, and then we store these embedding in the vector database. So this is basically this builds our vector database. After that, you can get the relevant documents. So once you have the vector chunks of the vector DB, you can ask your query and you provide the docs. So for this particular query, I can get the scores for the vector chunks, right? So here it is, OpenAI client embeddings.create. So this will gonna create the embeddings for me. So basically this will create the input query. So whatever query I am asking, it will convert these into the vector embeddings, as we saw in the RAG workflow in the slides. After that, it will calculate the score for the vector chunks. So all the vector chunks which I will have, it will gonna try to see how relevant these vector chunks are to my user query, and then it will take the top k vector chunks. Here I will consider it to be 5, so it will pick the top 5 relevant documents from the vector database on the basis of my user query highlighted here, and then it will return these documents along with the similarity score to me. And then I have an answer query model, which what it does is that it answers the query. So what it does is that it checks for the filtered relevant documents which we got from the RAG. If there is no filtered documents received from RAG, it will directly say no relevant information found. And if we have some relevant documents from the RAG, it will gonna put that data content and it will give it to the GPT-4 model. So here we are using GPT-4 as a model. It will provide these content as a context to the model along with the query, and it will let the model provide a response and it will return the response. Now we can run this. So we have defined all of this. The second thing is performing a web search. Now we use Tabule. Tabule is an open source software which allows a large language model to perform web search through tool calling. In the Tabule search, you define what are the maximum results you want, or basically what are the maximum search results you want. Here I am returning 5, so I want 5 top search results. After that, it will get the query and will try to perform a web search for it. So it will invoke the tool for the web search, and it will get the message back and it will convert that into the string. It will extract the answer of the search result and it will return the search result to the user. Now the interesting thing happens here is when I get the vector chunks, I get the vector chunks and the documents, and I provide this to the get relevant documents. Now get relevant documents will return the relevant documents as we explained above, but this relevant documents will also provide me the relevant documents along with their similarity score. So now we can check that we got the relevant document, top 5 relevant document from the vector database, and we also have the similarity score for it. And remember, we have a threshold. If the similarity score of all the documents is greater than 30%, or even one of the document is greater than 30%, we'll use that particular document and let the RAG answer the query on the basis of that document. If there is no document with the score threshold greater than 30%, we'll perform a web search. We'll assume that this particular query is not relevant. Okay. So the query I'm asking is, should I reconfirm my flight? Now this is a relevant query which you can make to an airline company, and if this particular query, if this can be answered, there will be a high relevancy score to the document and the model will try to answer it. So if I run it, this is running and this is getting the relevant documents. Now I have the relevant documents. I can run this and it will gonna first filter the documents with the score threshold. If the score threshold of all the documents is greater than 30%, then we'll have some filtered relevant documents, and then we will check if the length of the filtered relevant document is greater than 0, we'll let the RAG answer it. If the length of filtered documents is empty, or basically there is no filtered document or there is no relevant documents, we're gonna perform that search. So if I run this, you'll see the score. So these are the relevancy score of the documents, and you will see most of the documents have a relevancy score greater than 30%. So 40 to 43%, 40%, 35%, 33%, and 32%. And hence we get the RAG answer. So our RAG has answered the query like no reconfirmation of Swiss flight is not required. So the document which it fetched or extracted from the vector store, it has the answer to this to the query which we asked, and the model is able to answer it with the help of the context we provided. That is one thing. What if I comment this out, or let me uncomment this one and comment this out? So now this time I am asking how to make an Italian pizza. Now this is a kind of query which you cannot ask, or basically you cannot ask you basically not ask an airline company. So the airline company shouldn't be able to answer this. So if I run this, I'll get the relevant document, but this time the similarity score returned by the vector store for these documents should be lower than 30%. And that is why the filtered relevant document should get empty, and we should perform a web search like this. So if I run this again, you will see the relevancy score now, and the relevancy score of the documents are very low: 15%, 12%, 12%, 10%, and 9%, right? And hence it says like it filters out all these documents, and the filtered relevant document is now empty. So it says no relevant documents found. It goes here basically, and it says no relevant documents found with the sufficient similarity score, performing a web search. And it gives this query to the web search as we explained above in the method, and this is what we get from the web search. To make an Italian pizza, prepare a fermented dough, let it rest for 24 hours, shape it, add sauce, and bake it in a hot oven. Use a pizza stone for best results. Right? Now this is how you can build a fault-tolerant retrieval augmented generation workflow. So this is what I wanted to explain, and I'll quickly stop sharing and share back this slide. And I hope this was clear. So let me know, is this clear to everyone? Okay, the first thing is okay, cool. Let me share back. Okay, cool. I hope this walkthrough was understandable to everyone. And let's talk real for a minute. Many of you are inspired, and that's great. But let's not sugarcoat what lies ahead if you choose to do this alone. Here's the brutal truth. Even forward, and they don't fail because they are lazy, they fail because they have no roadmap, just scattered landmarks. And let's be honest, building Gen AI system isn't just about writing prompts anymore, as we have seen here in the session. And you need to know which tool to use, when to use, and why to use, and you need working pipelines from data into the agent output. And most importantly, you need feedback when you build. And the ones who don't, and this is the place where most people quit. The moment they either find mentorship or structured learning, and that's where the advanced certification in Gen AI and multi-agent system by Coding Ninjas comes into the picture. So this is what you will probably getting the skills, the projects, and the tools which will be explained in the program. Everything you saw is directly mapped to the module in the program, and if you are serious about making the career decision, don't try to bring it alone. Follow a proven roadmap and definitely enroll into the program. The link is shared in the chat, and you can fill the form. The link to the form is shared in the chat. You can fill it, and this is the structured 6-month roadmap, which you'll not find on YouTube or anywhere else. So you should definitely take a look at this. And with that, I will probably give the mic to the Coding Ninjas program expert, who is gonna tell you more about this, and I hope you enjoyed the session. So thank you very much.
Okay, so first of all, thank you so much for such an insightful and informative session taken. Now, before winding up the session, I'll just be giving you an overview of what we are actually providing being the part of this program by Coding Ninjas. So if we talk about some highlights of this program, so this will be a 6 months live program wherein once upon enrollment, you will be getting a welcome kit through us, which will be having letter, t-shirt, sitter kind of things. You will have your orientation done from IIT Mandi, and you will be getting some guest lectures that too from IIT Mandi itself. Once upon successful completion of the program, you will have a one-day campus immersion for certification ceremony, 10 plus general projects to work upon your skill sets, to practically implement, to sharpen your skill sets, whatever you have learned being the part of this program. 24/7 AI support so that you can clear all the doubts and queries, whatever you have then and there in the portal itself. So you will not have to wait for another live class, another mentor to be available to join in and help with your doubts. With the help of 24/7 AI support, you will be able to clear all the doubts and queries then and there itself. Career services, wherein we will be helping you with resume review. You will have the job portal access of MSDC as well, so that you can hunt for the job roles. And after a successful completion of the program, after successful upskillment, you will find yourself ideal to hunt for the job roles like GNA engineer, multi-agent systems developer, and many more job roles, guys. So once again, this was just an overview. If you want to know more about it, you can simply go into the chat box. There is this form link. Click on the link, fill in your basic details, and get a chance to get in connect with our counselors one-on-one. As that will be a one-on-one conversation, so you'll be able to clear all the doubts and queries then and there as well. We'll be helping you to deep dive into it to know exactly how this can impact your goals that you have set for yourself. May it be growing into the same domain that you're working, may it be changing out of the domain. Whatever the requirements you have, we will be helping you out to understand it in the best way possible to deep dive into it. And then after the whole discussion, if it seems like this is something that you are looking for, this is something a perfect fit for you, we'll be helping you to get enrolled in one of our upcoming batches as well, guys. So this was it from my end, guys. I will just be waiting for another 1 to 2 minutes before winding up the session, so that the people who have not filled in the form yet can still do so, and then we'll be calling our masterclass for the day. Okay, so once again, thank you so much for your lovely participation in the masterclass, guys. We hope to see each and every one of you in our upcoming batches for the program itself. Till then, best of luck, guys. The masterclass is over now. Good night.